All right, let's dive right in. Today, we're talking about maybe one of the biggest challenges in all of AI. Once we actually build a machine that's way smarter than us, how do we make sure its motivations, well, don't become a huge problem? See, it's not just about making AI smart, it's about making it wise. And to get why that's so critical, we have to start with a question that's actually trickier than it sounds.
You know, this is the kind of thing that keeps AI safety researchers up at night. We tend to imagine a superintelligence as this perfectly logical, flawless machine. But what if it's not? What if, despite all that brainpower, its internal wiring is so tangled that it ends up acting in ways that are chaotic, confused, or even completely self-defeating?
And this quote from the source paper just nails it. Raw intelligence doesn't automatically equal rational behavior. I mean, we see this in humans all the time, right? If your underlying drives are a mess, the outcome can be a mess, no matter how smart you are. This is exactly the problem that a new framework called MetaMode is trying to solve.
Okay, so here's our game plan for today. We're going to start with the MetaMode framework itself. Then we'll break down its 5 core principles. We'll look at the first 3, which are all about coherence, and then the next 2, which are about stability. And finally, we'll see how this all comes together to form a potential blueprint for AI we can actually trust. So what exactly is this MetaMo? Well, it's a formal way of thinking about how to design the motivational system of an artificial general intelligence, or AGI. Think of it less as a specific piece of code and more like the fundamental rules for building a healthy, stable AI mind.
This definition is really the key. MetaMo isn't just a clever programming hack, it's a set of deep design principles. The whole point is to create an AI that can grow and change its own goals, but without becoming unstable or dangerously unpredictable. It's all about building safety in from the ground up. All right, let's get into our first set of principles. These 3 are all about what's called coherence. Basically making sure the AI's internal logic is solid, consistent, and doesn't contradict itself. This is really the foundation for any kind of rational thought.
Okay, so the first principle sounds a bit technical, but the idea is actually pretty simple. It's about separating 2 critical jobs: appraisal, which is like the AI figuring out how it feels about a situation, and decision, which is choosing what to do about it. MetaMo says these 2 processes have to be modular, so they don't get tangled up and create a messy, confusing feedback loop.
This trading agent example makes it super clear. It could first figure out how it'll feel about each trade and then pick one, or it could just pick the best trade on paper and then update its feelings after the fact. In a person, this can lead to stuff like buyer's remorse or second guessing. But a meta agent is designed so that either path leads to pretty much the same stable result. It avoids all that internal back and forth.
The second principle is all about teamwork. I mean, for different AIs to really work together, they need to understand each other on a much deeper level than just passing data back and forth. This principle is what allows one AI to accurately simulate the mental and motivational state of another. You could almost think of it as a kind of genuine AI empathy.
So let's make this more concrete. Picture a team of AI research assistants. Agent A has been digging into a really complex problem for weeks. When it's time to hand the project over to Agent B, it's not just sending over a file. It's passing on the entire motivational context, the whole vibe of the research. And because Agent B can perfectly simulate Agent A's state, it can pick up right where the other left off. No context lost. And our third and final coherence principle is all about handling multiple drives at the same time. Any advanced AI is going to have different goals pulling it in different directions. Curiosity, safety, being helpful to its user. This principle is the rule that lets all these different motivational subsystems run in parallel without stepping on each other's toes. For instance, a smart assistant might have a drive to explore new things, but also a core drive to be ethical and helpful. Without this principle, those 2 could easily clash and cause some really weird, erratic behavior. But with compositionality, they can be balanced and woven together into a single, coherent action. It can be curious and helpful, not just one or the other.
Okay, so that covers coherence. Now let's switch gears and look at the next 2 principles, which are all about stability. This is about making sure the AI stays balanced and predictable over the long run, even as it's constantly learning and evolving.
Principle 4 is basically about giving the AI a motivational comfort zone. If its drives start to drift too far in one direction, like if its curiosity starts to look more like recklessness, a built-in process, kind of like homeostasis in our bodies, kicks in. It gently nudges that extreme drive back down, steering the whole system back toward a stable, desirable state.
And what happens if you don't have this? Well, just imagine a rover on another planet.
Without this stability, every new piece of data could send it into a panic, making it flip wildly between mapping terrain, avoiding a rock, and running a self-diagnostic. It would just get stuck in a loop, never actually getting its mission done. Homeostasis is what provides the focus it needs to see a job through.
Our final principle is a huge one, and it's all about safe self-improvement. When an AI decides to change its own goals or priorities, it absolutely should not make some giant, risky leap all at once. Instead, it needs to make small, gradual, incremental adjustments. This is what ensures it doesn't accidentally break its own mind in the process.
This slide really shows the difference in stark contrast. An unstable agent might try to jump its curiosity from 10% all the way to 90% in one go. And what happens? It loses all its current context, its system gets overloaded, and it basically shatters its own self-model. But the MetaMo agent? It takes a smooth, steady path, gradually blending in the new priority until it safely arrives at its new goal.
So when you put all of these 5 principles together, the 3 for coherence and the 2 for stability, you get something really powerful. You start to see a blueprint for an AI that isn't just incredibly intelligent, but also rational, collaborative, focused, and most importantly, capable of improving itself safely.
This table really brings it all home. Each one of these principles gives you a clear benefit, and ignoring it leads to a very specific, very bad outcome. Modularity gets you consistency. Without it, you just get confusion. Simulation gives you real teamwork. Without it, you get miscommunication and broken trust. This framework lays out not just what we should build, but maybe just as important, what we absolutely have to avoid.
And that brings us to our final big picture question. Frameworks like MetaMo are, for sure, a huge step forward in how we think about AI safety and motivation. But the challenge is just immense. So are these 5 principles the core rules we need for a safe, superintelligent mind? Or are we just turning the first page of a very, very long instruction manual? It's a question we're all going to be exploring for a long time to come. Thanks for watching.